All right, and here's the parent function. So f of x equals square root of x. So here's the parent function. If I input 0, square root of 0 is 0, so I get output of 0. If I input 1, square root of 1 is 1. If I input 4, square root of 4 is 2. And if I input 9, square root of 9 is 3, right? So those are my input-output relationships. And once again, if you see, it's actually it's a quadratic flipped around, right? With a quadratic, if you input 1, 2, 3, you get 1, 4, 9, etc., right? When you square them, you get those. So anyway, so this is what it looks like. So once again, it's kind of a sideways parabola, and it does have a stopping point. So the domain would be not negative infinity to infinity like with polynomials. It would be 0 to positive infinity, right? And one mistake here, I need to fix this, right? Because it does get to 0, so that's going to be, that should be a bracket there. So 0 to infinity. And then the range is going to be the same, right? It's actually 0 to infinity as well, because it starts at 0, 0, and then it goes up forever. Even though it goes up kind of slowly, it still is going to keep continuing up and up forever, okay? All right, so that's the domain and range of the parent function, right? So we're going to be asked to graph and find the domain and range of these functions on these next few examples. So take a look at number 7 here. So we're going to use kind of our transformational skills and also our knowing our parent function, okay? So graph each function, state the domain and range of each function. All right, so this one. So so what's happening? This is the parent function, but I have a negative out front. So remember, if you have a negative out front, like outside the parentheses or outside of whatever's happening with the function, in this case outside the radical, that means it's going to be a reflection across the x-axis, right? It's going to be a vertical change. So instead of it starting out like this and going up, it's going to go upside down the other way, right? So it's going to be something like this, right? Now that's not exactly it, so I'm not going to leave that there, but then because I want to evaluate this other transformation, okay? So here we have reflection across the x-axis, right? And then now let's evaluate what this 3 does. So the 3 is inside, so it's going to be a horizontal change, and we're multiplying by 3. So generally you would think multiplying by 3 stretches it, but since it's inside, it's backwards, actually going to compress it. And so it's going to be a horizontal compression by a factor of 3. Okay, so it's going to be something that kind of smushes the graph this way and this way, right? So so if I plug in so in order to get, let's say like before when we plugged in 1, we got 1, right? Now I'd have to plug in 1/3 to get 1, right? So if I plugged in 1/3, I would get 1. So it'd be like right here, right? In order to get 4, I would have to plug in 4/3. So 4/3 times 3 is 4, and the square root of 4 is 2. So I'd have to plug in 4/3 to get 2. So 4/3 2 would be something like right here. And the reason I'm going negative is because it's flipped, right? And so then if I want to get 9, I'd have to plug in 3, right? So 3 times 3 is 9. Okay, but I would get out -9, of course, because the negative in front, and so forth and so on, right? So it's going to be something that looks a little like this. So it's going to be a little kind of wider, deeper, not as shallow in terms of the horizontal width, right? Okay, so that'll be what the graph looks like. Now domain and range didn't change, right? Well, let me start all over. Domain didn't change because we still start at 0 and go to positive infinity. So, oops, bracket, start at 0, go to positive infinity. The range, however, I start at 0, but it's going to negative infinity, right? So actually 0 is the maximum in this case. So it's going up to 0, it's going down to negative infinity. So it's negative infinity is how far it goes down, and it goes up all the way to 0. Okay, so that's the range on that one. So when you reflect across the x-axis, that's going to flip the range, right? So instead of going from 0 to infinity, it's going to go from negative infinity to 0. All right, let's take a look at number 8. So here we have, and by the way, let me just erase this just so you can see. Yeah, so the answer would just be that graph and then the domain and range, right? Okay, so number 8, we know the original parent function. Let's just draw it out again. We know it goes through 0, 0, 1, 1, 0, 0, 1, 1, 4, 2, and 9, 3, right? So it's going to be something like this. Okay, and so what we're doing, the only thing we're doing on this one is we're multiplying by 2 on the outside. So that's going to be a vertical change, and we multiply by 2, it's actually going to be a stretch. Okay, so all these points that we had before are going to be stretched by a factor of 2. So when we plug in 1, instead of getting out 1, we're going to get out 2. When we plug in 4, instead of getting out 2, we're going to get out 4. All right, when we plug in 9, instead of getting out 3, we're going to get out 9. So that's going to be way up there. Okay, so it's a vertical stretch by a factor of 2. So we'll still start at 0 because when we plug in 0, 0 times 2 is just still 0. So, so that doesn't stretch. So it's going to be like this. All right, and so once again, our domain is still the same. 0 to infinity. Still starts at 0. The farthest it goes left is 0, but then it goes right forever. And then the range still starts at 0 as far as how it goes down, and then it goes up forever. So domain and range are actually 0 to infinity on that one, just like the parent function. All right. Now number 9 and 10. Now we start getting into some different types of transformations, where we are, and those are translations, right? We had some reflections before, and vertical stretches and compressions, and horizontal stretches and compressions, but now we're actually getting into where we're adding and subtracting, and so that's going to get us into some translations, right, where we're moving left, up, right, up, down. Okay, so let me start out with number 10 because I think it's a little easier. So this one, so remember, whatever's inside here, that's going to move it left or right if we're adding or subtracting, and positive moves it to the left. So this is going to go left 4, okay? And then negative 2 on the outside, that's going to move it down 2, just like you would think. So left 4, down 2, okay? And we've actually had a question just like this on quizzes and tests before and assignments, right, where you told me that was the transformation. So the parent function looks like this, right? And so what we're going to do is we're going to take that. We don't have any reflections, we don't have any stretches or compressions, so we're just going to take that and move it left 4 and down 2. So it's going to be right here. That's where it's going to start. So I'm just taking this vertex value here, or the starting point, and I'm moving it left 4 and down 2. So I get here. And then I'm just going to graph the same thing. It goes up 1 over 1, and then it goes up 2 over 4, right? So it's going to actually have a point there. So it'll just be something like this. Do a little better with that. All right, so same graph, but it just changes locations. All right, so now when we talk about domain and range, that changes now, right? So now how far, so remember, domain is always how far it goes left. So how far does this go left? It goes left to negative 4. So that's the left endpoint, and it's going to be, it's going to have a bracket there because it reaches there, right? There's a closed circle there. How far does it go right? Infinity. It goes right forever. Okay, now the range. How far does it go down? It goes down to negative 2. How far does it go up? It goes up forever. Okay. All right. So anyway, so that's the domain and range of that particular function. Now, one thing I want to mention with radicals is we can't go below the x-axis, right, or with the parent function, with the square root function, because if we go below the x-axis, that's where or we can't, excuse me, we can't go to the left of the y-axis, because then our inputs become negative, right? And as soon as we start having negative inputs into a square root function, we start getting imaginary numbers, right? And so that's why the graph stops at 0, algebraically, okay? So when you have a function like this, a square root function, the limitation on it is that this, what's underneath the radical, the radicand of a square root function has to be greater than or equal to 0, right? If the radicand is less than 0, you're going to have a negative underneath the radical, and that'll turn into an imaginary number, right? Like, for example, if I plug in -5 into this function, -5 plus 4 is -1, and that would give you the square root of -1, which is I. And even though we know how to operate with imaginary numbers, they still aren't real. They don't show up on a graph, right? Like, we don't have anything to plot for that. So that's kind of part of how you can find your domain, is setting the radicand greater than or equal to 0. Okay, so for example, if the radicand is x plus 4, you can say, okay, well, x plus 4 has to be greater than or equal to 0, and then you can solve for x. So you can just subtract 4 from both sides, and so then we get x is greater than or equal to 4, to -4, and that's what this says, right? So that's one way to find the domain when you're given a radical, is to take the radicand and set it greater than or equal to 0. Okay, and that's what we'll do here, because this one's a little tricky, because we have that 2 there, and that's going to be a horizontal compression by a factor of 1/2. But because we have the -5 there, it doesn't actually move it down, or it doesn't move it right 5 because of that 2. Okay, so let me show you what I mean. So if I just say, okay, well, 2x minus 5 is greater than or equal to 0. So I know that this can't be negative, right? So in other words, it has to be greater than or equal to 0. So this will help me find my domain. So then I can add 5 to both sides, and I would get 2x is greater than or equal to 5. And then I would divide by 2, and I would get x is greater than or equal to 5/2, right? So 5/2 is actually where this is going to start, right? So 5/2 is going to be my my starting point. So 5/2, 2 and 2.5, right, is another way to think of it. So it'll be right here. And since there's nothing out here, it's not going to go up or down, so it's going to stay on the x-axis. So that's where it's going to start, okay? All right, so instead of moving over 5 to the right, it actually moves 5/2, right? So if you have a coefficient there that's not outside of the parentheses, it's just in front of x, you actually have to divide that to get your shift, to get your translation, okay? Anyway, so that was a little tricky. So that's the domain. So domain is going to be from positive 5/2 all the way to infinity. All right, now the range is a little tricky. So here we have a negative out front, so that's going to be a reflection across the x-axis, right? So that's going to make it go upside down. All right, and remember, it's also a horizontal compression by a factor of 1/2, right? So I'd have to plug in 1/2 to get 1, so it can be like right there. I'd have to plug in 2 to get 4, or 2 to get yeah, and if I take the square root of 4, that comes out to 2, so then it'd be like this right here. Okay, and so forth and so on. So it'd be something like that. All right, so the range is going to be, how far does it go down? It goes down forever. So negative infinity is our left endpoint. How far does it go up? It goes up to 0. So because I didn't have any shift up or down. So all right, so that's how you find domain and range of these. So if you have more than just x, or as long as you have more than just a monomial inside the radical, the square root, then you're going to set the radicand greater than or equal to 0, and that'll help you find your domain, right? And by the way, if you want to just put your domain as x is greater than or equal to 5/2, that's fine too. You can, either of these mean the same thing, so they're interchangeable. All right, everybody. So let me know if you have any questions, and we'll get a lot of practice in class with this. So this is the only kind of question really that we'll have, is just graphing, finding the domain and range and graphing these radical functions. Just kind of get used to them. All right.